Hey guys, I'm going to do just an example of an explosion. Okay, so let's take a peek at like what's happening here in this example. What I've written on here was momentum. Um, we'll say before is momentum after. M1 V1 is equal to M2 V2. Okay, so here's my picture. So I've got a cannon. A cannonball in here. And what I'm given is a situation where there's we'll say the mass of the ball is 5 kilograms. The mass of the cannon is 300 kilograms. Let's say the velocity, when we shoot this off, okay, this becomes separated from this. So the velocity of the cannon is it says is 5 meters a second, but we're going to call that 5 meters per second backwards. Okay. Okay. So we got a velocity that the cannon recoils at. If you've ever shot a gun or anything like that, you know that there's always a recoil. And then we'll say the cannon. Okay, and it wants to know what the velocity of the ball is, the cannonball. Okay, so we've got a rather simple equation which tells us that M1 V1 is M2 V2. So let's just solve it out. M1 V1 is M2 V2. Okay, M1 we'll call the mass. This one here, we'll say we're looking for the velocity of the ball. So let's just find the momentum of the system first. So we've got 300 times -5, okay, equals, we're going to put a negative sign in here because we know it's going to go the opposite way. M2, which is, we'll call this 5 kilograms, times the velocity of the ball. Okay, so if we know the recoil velocity, we can come up with the velocity of the ball. So 300 times 5. Okay, 1,500 kilogram meters per second. That's the momentum before. It's got to equal the momentum after. So let's just solve this. 5 kgs times v of the ball. Okay, so let's solve for that. So 1,500 equals 5 v Okay, I divided out that, and I found out that the velocity of the ball is 300 meters per second. Okay, we'll do one more just to solidify this for you. Okay, you might want to pause this and write this down. M1 V1 is equal to the negative of M2 V2. Momentum is conserved. Okay, one more example I'll give you is we'll change it over to like a rifle. Okay. Okay, let's say we've got a rifle that's going to shoot a bullet out. We want to know the velocity of the bullet. All right, so I'm going to give you the mass of the gun. I'm going to give you the mass of the bullet. I'm going to give you the recoil velocity of the gun. That's this. Okay, and we're going to look at what the velocity of the bullet is. So given that we know momentum before equals negative momentum after, we're going to take a look at M1 V1 is M2 V2. Okay, so M1 V1, we have that. Mass of the gun, we're going to say, is 3 kilograms. Mass of the bullet, 0.01 kilograms. Velocity of the gun, the recoil velocity, I'll give that to you as well. We'll say it's 4 meters a second negative. We want to know what the velocity of the bullet is based on the recoil velocity. It's assuming there's no springs in there, because that changes things a little bit. So M1 V1, M2 V2. Let's find the momentum of that system. M1 is the mass of the gun, 3 kilograms. Velocity of the gun, negative 4 meters a second. M2 is our 0.01 kilograms, a bullet. And then the V2 is the velocity of the bullet we're looking for. So negative 12 equals 0.01 kilograms times the velocity of the bullet. Okay, it becomes a simple division process. We're going to get rid of 0.01, 0.01. And we're going to come up with velocity of the bullet is equal to 1,200 meters per second. Okay, and that's going in that direction. Okay, so I think it's pretty cool that we can take our conservation properties and we can relate them to how fast the bullet's coming out of a gun just based on the recoil velocity of that gun. Okay, let's take a look at another one where we have 2 rail cars that are at rest. And the mass, we'll call this A and B. The mass of A is 4,000 kilograms. Mass of B is, we'll say, 6,000 kilograms. Okay, the initial velocity of this whole system is 0. Let's say we have a small explosion here. Bang-o. Okay, right in between here, explodes those cars, and then they head off in their opposite directions. So you've got A here. It's going to move this way. And you got B, it's going to move this way. Okay, so my question is, it says the velocity of A is 6 meters a second. Okay, that's A. We'll call it -6 because it's going to pop this way. We want to know what velocity of this one is going to be. Okay, that's the question mark. So since our M1 V1 is M2 V2, okay, this and this, okay, we can figure out what the momentum is based on this and figure out the velocity just like we did with the gun. Okay, so let's look at it. 4,000 kilograms, M1. V1, it says that it heads off at -6 meters per second. That's equivalent to our 6,000 kilogram unit, that one, times the velocity of that second unit. Okay, so we multiply these two together. We get -24,000 kilogram meters per second equals 6,000 kilogram, and then velocity of whatever that second one is. And we've done this so we can do this math very easily. All right, divide by 6,000. Get rid of that. You get the velocity on this side. 24,000 divided by 6,000 is 4 meters per second. Okay, so the velocity of B would be 4 meters per second. And just by the picture, we know it's got to go in the opposite direction. I put a negative here to show that this is equal to the opposite of that. But even if you forget your negative sign, you can look back at the picture and say, hey, if A's negative, then B's got to be positive. So that's 4 meters a second for the velocity of the train. I'll leave that up for a second so you can take a peek at it.